This next section will feel much easier than 4.1. I would say 4.1 is kind of the crux of chapter 4, and everything kind of gets easier after here. What we're going to look at here is just polynomials and adding and subtracting polynomials. So, what is a polynomial? Well, a polynomial is made up of terms, and terms are numbers, which could be constant if there's no variable with them, a variable or the product or quotient of a number and one or more variables raised to powers. Horrible definition. Better to see what they are. So a term could be something like 4x, right? This is a number and a variable where the exponent is a whole number. In other words, a 1, a 2, a 3, or a 4. This is another example of a term. This is another example of a term. This is an example of a term because everything's multiplying together. This is an example of a term. This is still one term because everything's multiplying together. But what we're going to really focus on is the terms that could be part of a polynomial, which, like this one, wouldn't be classified as part of a polynomial expression because it's got a square root. So it's these nice simple ones where it's like an x or an x squared or an xy squared and so on. The numerical coefficient of a term is the number that's in front. So if you look at ax to the n, it would be the a. And the degree is the exponent on your variable. If there was more than one variable, so for example, if it was an xy cubed or squared, it would be them added together. So this would be a degree of 3. But I've purposely left that out of this note because we're not going to be looking at ones that have more than one variable. So if I'm telling you that this is a term, the 12 is the coefficient and the 9 is the degree. Simple as that. So what about these next 4 examples? So if you have 3x, the numerical coefficient is 3. What's the degree? Well, the degree is the exponent on the variable. If there isn't one written there, it's a 1. What about this guy? This is a constant term, meaning that there is no variable to change it. There's no letter. The numerical coefficient we will say is -6, but then what's the exponent on the variable? Well, there is no variable. And if there is no variable, that means it's 1, which means the exponent must have been a 0. For this one, the numerical coefficient, there's that hidden 1, so it would be -1 with a degree of 4. And for this one, it would be a lot easier to see it written as 1/3 x squared. You can then see that the numerical coefficient is 1/3 and that the degree is 2. So now let's focus on that idea of a polynomial being made up of many terms, where those terms need to be in the form ax to the n, where a is a real number, x is a variable, and here's what I was talking about earlier, is that the exponent must be a whole number, meaning 0, 1, 2, 3, 4, and so on. No negative exponents, no radicals, no exponents in denominators. So if I asked you, giving that definition, which of the following are polynomials, I'll give you a hint. 3 are and 3 aren't. Can you identify the 3 expressions that are polynomial? Well, this one, and this one. This one is not because this exponent is not a whole number. This one is not because it has the radical. And this one is not because the x is in a denominator, which you could write as x to the -1. Okay? When you have a polynomial expression, which is one or more terms, you write them in descending orders of power. Meaning this would be an exponent of 5, 2, 1, 0. In these polynomial expressions, the leading term is always the term with the highest degree. So for this example above, the leading term would be x to the 5, which is going to make this a 5th degree equation. And the leading coefficient is just the number that would be in front, which in this case would be 1. And from that, you can get a lot of information about what the graph would look like, which we do more in Math 60. So for now, you could just go, oh, look, the highest degree is a 5. This is a 5th degree equation where the leading term is x to the 5 and has a leading coefficient of 1. The next little bit we want to talk about is some polynomials with a specific number of terms are given special names. So instead of calling it a polynomial, meaning many terms, a single term polynomial is called a monomial. meaning that there's just one term in the expression. A two-term polynomial is called a binomial, and a three-term polynomial is called a trinomial. Once you pass the trinomial level, you just simply call it poly, right? So that you don't specify how many terms are in the expression. So here's a question. I've kind of combined two textbook questions together in one. So the first question being, write the polynomial in descending orders of power of the variable, then give the leading term and the leading coefficient. That'll be one question in your textbook. And then the second question is, identify each polynomial as a monomial, binomial, trinomial, or none of these. And it's funny that the textbook says none of these. If it's none of these, it's just polynomial. And then lastly, give the degree. So this is two separate questions in your textbook that I just combined into one. So let's take this guy, let's write it in descending orders of power first. So this is my highest power, so I'm going to write the negative 2x cubed first. Always take the sign with it. Then I'm going to write the 3x squared, and then I'm going to write the 1. So I've written in descending orders of power. The leading term, we'll just put LT, is negative 2x cubed, and then my leading coefficient is just the negative 2. Identify this polynomial as monomial, binomial, or trinomial. Well, because there's three terms, we'll call this a trinomial. And then lastly, give the degree. So since I've written this in descending orders of power, my degree is going to be the exponent on the leading term, which will be a third degree. All right, next one. Okay, pause the video if you want, but you're just going to write this in descending orders of power. So we'll go z to the 5, negative 3, z to the 4. Oh, that 4 looks like a 9. Good. Okay, where am I? Z to the 4, negative 3, z to the 4, plus 2, z to the 3, plus 6, z. The leading term is z to the 5. The leading coefficient is 1. It is 1, 2, 3, 4 terms, so the textbook would say none of these, but I do want you to know that this is a polynomial. It's just not mono, bi, or tri. And then lastly, the degree would be 5, or you could call it a fifth degree equation. Awesome.